Hello everyone, my name is Jonathan Flores. In this video I will explain the implementation and simulation of a clock divider circuit using VGL in Quartus Prime and Questa Intel FPGA. The main objective of this project is to divide the frequency of a 50 MHz clock signal from the FPGA board into a lower and more manageable frequency using a binary counter. Here we can see the VGL code of the clock divider. Inside the architecture we define a 26-bit signal called clock temp, which acts as a counter. Each time the 50 MHz clock rises, the counter increases by 1, and the output signal clock out is assigned to bit 23 of the counter, which divides the original clock by 2 elevated 23. Next, we have the test bench that provides the clock and reset signals to the design. The test bench generates a 50 MHz square wave by alternating high and low states every 10 nanoseconds. And we are going to compile our code. Okay, now we're going to select processing, tools, and the netlist viewer to see our schematic. And this is our schematic for the code from the clock divider. Now we're going to run the simulation with the RTL simulation, and we launch the simulation in Questa Intel FPGA. Okay, here we add the signal slug 50 MHz, click clock out and reset clock to the waveform window to visualize the behavior of the systems. And once we run the simulation, we clearly observe that the output signals toggles at a much slower rate compared to the input clock, confirming that the division process works correctly. For now, we're gonna change their names. And we're gonna change to 160 nanoseconds. And now we run a simulation, and as we can see, we can see our signals toggles at a much slower rate. Okay, in the waveform, the upper trace corresponds to the 50 MHz input clock, while the lower trace shows the divided output clock. Finally, the design was implemented on the FPGA board